So,
How did you fall in the paper hurt you?
folding the paper hurts your ribs.
No, like I'm picking up stuff off the floor and it hurt me.
Does that get too dark?
No.
Can you all see?
Yes.
Anybody have an issue? If you have an issue, raise your hand. All right. All right. So, okay. These are all of your steps to factoring out a GCF. GCF stands for
Greatest common factor.
greatest common factor. Okay, it's what every piece of your polynomial has in common. So that could be numbers. That could be variables. Okay, they can share both. So I do what I call upside down division. Okay, I think it's easier. So I'm going to show you how I do that. So it says write the polynomial under the upside down division sign. Your second step, find a number that divides evenly into each coefficient and your constant. Don't forget, it has to be every term. We then divide by this common factor and keep dividing by other factors until the only number that divides into each term is a 1. Okay? You divide by any variables that each term has in common. The GCF is found on the outside of the division sign. We place parentheses around the terms at the bottom and write your answer with the GCF on the outside of the parentheses. Okay, so if you ever need to go back and review your steps, they are all right there for you. Okay, we've got 4 examples we're going to do.
This seems so long.
It's really not. It seems long and wordy, but it's really, really not when we actually get down to it. Okay. So, this is your first problem. Okay, so what they want you to do is put this upside down division sign. Okay, so there's your upside down division sign. Normally it goes up and across, this one goes down and across. It's reflective. Okay. All right. Now you need to look at all of your numbers. We have an 18, a 15, a 3, and a 6. Is there any number that divides evenly into each one, Jeremiah?
Is it a 3?
It's a 3.
3.
Okay, so the 3 goes on the outside. You're now going to divide each one of these numbers by 3. So, Mo, what's 18 divided by 3? 6. Okay, you keep your y squared. Minus, Elijah, what's 15 divided by 3? 5. Y cubed plus, let's see. Kate, what's 3 divided by 3? 1.
Y.
Okay, you don't have to write the 1. So this is just y. Let's see. Minus. What can I pick on? Justin, what's 6 divided by 3?
Sleep.
Sleep. No.
2.
2. He says sleep. Okay. So now we have a 6, a 5, a 1, and a 2. Is there anything else that divides evenly besides 1?
No.
No. I'm done with my numbers.
It's because of the 5. It's the 5's fault.
Actually, it's the 1's fault.
Why is it the 1's fault?
Because what goes into 1 besides 1?
Oh, yeah.
So technically, it's the 1 and the 5's fault. Okay. Well, 5 is divisible by 5, so.
Yeah, but no, because 6 is divisible by 5.
Okay. All right. So now you need to look at your variables. Okay. My first term has 2 y's. My second term has 3 y's. My third term has 1 y. And my last term has none. Do they share y's in common?
No.
Every last one of them. Do they all have a y?
No.
No. So you can't pull any y's out. So that means we're finished.
Woo!
So your final answer, your greatest common factor goes out front. Your 3. And then you put parentheses and everything below it goes underneath.
I remember this from last year.
Okay.
It wasn't that bad to me. He just didn't teach it a lot. He just did it like once or twice. Yeah.
So what you've just done, if I sit here and if I take this 3 and distribute it back through, I should get this answer. Okay. So that's a good way to double check yourself. You're done with that's it. We're just pulling out your greatest common factor right now.
Is that all we have to do on the exam?
Oh, we're going to get deeper into factoring today. It's okay. So, scoot on down to the bottom one.
I don't want to do that.
You don't want to do this one? Okay. So, we need to look at this. I've got a 45. What's here? 1. 15. 5. Okay. Do I have a number that divides into evenly to all?
5. No, because it's a 1 in there.
There's a 1 here. 1's not divisible by 5.
God dang it.
So you cannot divide into anything except for 1. So there is no numbers that they share in common. Now we need to look at each variable individually. I have 3 x's, 1 x, 2 x's, and 1 x. What do they share in common?
1.
1 x. So we pull out an x. Okay, we pull out an x. So that means each one of these go down by x. So we're left with 45x squared. Wait, what? Okay, one variable at a time. Don't jump ahead. No, don't jump ahead because you're going to confuse everybody. Please do not jump ahead. We will get there. I need to keep everybody on the same page. So the only thing that's changing right now is everybody's going down by an x. So this is just negative y squared z because it only had 1. Okay, and it went away. Plus 15. This one's down to x, bless you. Y to the 4th minus 5. And again, I only had 1 x here. So this drops to y z squared.
Oh, that's a lot.
Okay.
So
now, look at your y's. I have 2, 4, and 1. How many do they share in common? 1. So all of my y's are going down by 1 now. So we're at 45x squared, bless you, y, z to the 3rd, minus y, z, plus 15x, y to the 3rd, minus 5, z squared.
Dang it.
Okay. We move on because we've got one more variable. I've got 3, 1, 0, and 2. Do they share a z in common? No. What's my problem? There's no z there with the 15xy to the 3rd. So they do not share a z in common. So we're finished now. We did your numbers, we did your x's, your y's, your z's. So we finished this one. Your greatest common factor is over here on the side, xy. And inside the parentheses is everything that's below. So 45x squared, y, z to the 3rd, minus yz, plus 15, xy to the 3rd, minus 5, z squared.
When you were dividing by the first term.
Okay, I need the rest of you to be quiet. I have somebody asking a question, and you're being rude. Stop.
Okay. And when you said you were gonna get rid of all the x's, why didn't you get rid of the one that's like 45x 2y to x3 if the other one up there is x z? I'm saying that why you didn't get rid of the not the x one, the y, like first this y and then you didn't get rid of y2, besides x 45x, this still the same y2.
No, it's not. It became y here. This row is just when we remove the x's. This row is when we remove the y. So it did go down. But we didn't divide by the y until this step. So the y's didn't change until here. Okay. All right, 2 more. Okay. Check out this one. I've got a 32, a 16, and an 8. Okay? 8 goes into this one. Okay? 8 goes into this one. Daniel, how many times does 8 go into 32?
It goes in 4 times.
4 times. 8 goes into 32 4 times, so I'm left with 4x to the 4th. Okay? Let's see. Rebecca, how many times does 8 go into 16? 2. X to the 3rd plus. Cody, how many times does 8 go into 8? Once. I don't need to write it. It's just a coefficient in front of x squared, so we can just bring down x squared. Okay? So we took care of your numbers. I have 4, 2, and 1. Does anything else go into it besides 1? No. Okay? As soon as you have a coefficient of 1, there is nothing else that divides evenly except for 1. So you stop. Now we need to cover the x's. I've got 4 of them, 3 of them, and 2 of them. So 2. They share 2 in common. So that means we take out x squared.
You see, what confused me about this last year was that you see we had the 3 that we factored out the 2. If you want to go by the numbers, we can't do that when we keep this. But I understand.
Wait, what?
We were taught differently, very differently, and it was confusing.
Is this helping?
Yeah, it's easy. Now I understand it.
Yes. Yes.
Her dancing is killing me.
Always. Okay, so Shelby just made an observation. You take out the smallest amount, okay, every time. So that's how you remove your variables. You take out the smallest amount every time. So I'm taking away 2 x's each time now. So that means I'm left with 4x squared minus 2x plus.
That's it.
Okay, be careful. When you remove everything, no, it's a 1. Remember, you have that unwritten coefficient there. You cannot lose that. So when you take away all the variables and there was no coefficient left, don't forget to put your 1. Okay? So now, do they all share any x's in common anymore?
No.
No. So we're finished. So here's your greatest common factor, 8x squared. And inside the parentheses is 4x squared minus 2x plus 1.
Well, yeah, I'm gonna have
It's all coming back to you?
Whoa! What is this number?
Woo! Woo!
Alright, I quit.
Yes.
Okay, so like if you're doing that and you get like the 8 and then you get the x, but then they after you take away like the x, would it be like they all have the number in common after that, or would that just
You want to try to take care of all of your numbers first. So just deal with your numbers until you can't divide anything into it except for 1. Because if you start to do like number then variable then number then variable, you're going to be like, what?
Wait, what if you like get the number out and you still have?
You can do another number.
Okay, cool.
Okay, so I'm going, hold on. I'm gonna take that one. So I'm gonna run this one. Watch what I do here. I've got 82, 16, and 8. And y'all went, what the heck goes in all that? Because 82 is huge. Okay, so you can do 4, but I'm gonna start with 2. So I can show you what happens if you pick something else. If you don't know what goes into this, they're all even, correct?
Yes.
Which means they're all divisible by 2. So I'm going to divide by 2. Okay, yes, write this down. So hold on. I understand that. I'm trying to show you something. Hold on.
I'm asking you to What?
4 does work. Give me a second. Actually, no, 4 doesn't work. 4 doesn't work. It doesn't go into 82.
Because 4 divided, 4 goes into 8 twice and it'd be a remainder too. It'd be like 10.
Because what?
Focus.
If you do 82 divided by 4, 4 goes into 8 twice, minus 8, that leaves me with nothing, and I bring down the 2. 4 doesn't go into 2. So it doesn't go in either. So no, 4 is not going to work. Okay, so we're left with 41. X to the 4th, y to the 2nd, z to the 3rd. Minus 16. X to the 3rd, y to the 7th, z to the 11th. Oh, why did I not divide that? Never mind. Ignore me. 8, 8, 8. Sorry, I totally missed that. Okay, this one should be 4x squared, y to the 9th, z to the 2nd. I do apologize. That was not 16. It should have been 8. Okay. Now, Brandon said, well, what if you did that and you still had something else that would divide into it? You would continue that process. So let's say 41 came out to be 42 and they're all even again and you could pull out another 2. You would pull out that second 2. Okay, that's okay. So, for instance, actually, let's finish this one, and then I'm going to make up one on here so you can see how that works. Okay, let's finish this one first. So, I don't know. Okay, X's. I've got 4 of them, 3 of them, and 2 of them. X squared. So we become 41. X squared, y squared, z to the 3rd, minus 8x, y to the 7th, z to the 11th, plus 4, y to the 9th, z to the 2nd. How many y's do I need to pull out?
2.
Only 2. The first one has 2, the second one has 7, and the last one has 9. So they only share 2 in common. So we've got 41, x squared. Those go away, z to the 3rd, minus 8x. That becomes y to the 5th, z to the 11th, plus 4. That becomes y to the 7th, z to the 2nd. Woo! One more. We got this. One more. All these numbers. How many z's? 2. 2 again, because I've got 3, 11, and 2. So we lose 2 of them. Z squared. So 41, x squared, z, minus 8, x, y to the 5th, z to the 9th, plus 4, y to the 7th. Whew! Now you're done.
You said about it's just tedious.
It is. It's tedious. Now, as you get better at it, you can pull the x, y's, and z's out at the same time. I'm starting y'all off slow because I don't want you to miss anything. So if you need to go the route where you do each individual part, that's okay. Okay? If you get really good at it and you want to pull all your x's, z's, and y's out at the same time, go for it. Okay. So, don't we have a what? A +1? No. We would have had a +1 if like everything over here would have disappeared. But I still have all 3 of my terms. Okay, if you start with 3 terms when you have a greatest common factor, you should end with 3 terms. Okay, remember your terms are separated by addition and subtraction signs. So my final answers: 2x squared, y squared, z squared, times the quantity of 41, x squared z, minus 8, xy to the 5th, z to the 9th, plus 4, y to the 7th. Okay. Find a spot somewhere. I'm going to go directly in the middle. Okay. Find a spot somewhere. I'm going to go directly in the middle. Let's do 64 x squared minus 32 x plus 16.
She just wrote
This is going to be the in class. We're going to do this now work.
Easy though, make it the whole word. The one in the middle of the paper.
But we already did it.
No.
Okay, so I want to show you what happens if you don't pick the biggest number that goes in. Okay, so again, each one of these are even. Most of you can look at this and say, okay, 8, 16, whatever. Yes, ma'am.
Are we writing this and just go?
Yes, no, write this in there. Just pick a random spot in there that you have a little bit of space.
Can I do it with the biggest?
Okay. No, I want you to have an example on how to do this if you can't find the biggest number at first. Okay, so we know these are all even, so we can divide by 2. Okay, that leaves me with 32, 16, and 8. I've got 32, 16, and 8. Guess what? We can pull out another 2. So I'm going to pull out another 2. That leaves me with 16, 8, and 4. Well, 16, 8, and 4. We can pull out another 2. So we're left with 8, 4, and 2. We can pull out another 2. So we're left with 4, 2, and finally 1. Okay. 2 divided by 2 is 1. Okay. Again, you started with 3 terms, 64x squared, negative 32x, and positive 16. You should always finish with 3. So we've got 4x squared minus 2x, and you're 1. Okay. So now we have no x's in common. Your greatest common factor is 2 times 2 times 2 times 2. So that gives me 16. 4x squared minus 2x plus 1. So if you ever end up where you have to pull out more than one number to finish off, you just multiply all your numbers together.
So if it's the same number, like the 2, you multiply it, or if
it could have been anything. We could have pulled out, okay, so we could have started here where it was 64x squared minus 32x plus 16, and we could have started with 4. How many times does 4 go into 64?
16. No, it's 4.
12.
No, wait, 16.
Oh.
Yeah,
16, you're good.
Ha.
16x squared, how many times does it go into 32?
8.
Minus 8x
2.
and 4.
Oh. Ha.
Okay. Now what goes into each one of these? We could have done 2. Okay. So that took me to 8 and 4 and 2.
Once you end up with the same number though.
And then I would have pulled out another 2, which would have taken me to the 4 and the 2 and the 1. So again, 4 times 2 is 8 times 2 is 16. So either way, you still end up with that final answer. Okay. Yes, sir.
Couldn't you have used 8?
Yeah, you could have used 8. Okay. If you were good enough, you would have pulled out 16 right off the bat. Sometimes, though, when you deal with such big numbers, you're like, wait, what? What goes into these? So start off small. It's okay. It's okay to start off small. Okay, this is going to glue in on page 43, my friends. 43.
What about you, Judy?
Okay, this is not homework. This is now work. Okay, I want everybody to start this individually. Pull out your greatest common factors.
What about this paper?
Over this paper.
Yes, that's not my there.
You will get to it, hopefully. If not, there's always Monday. Which means there won't be homework tonight because you don't know how to do it. I figured you guys wouldn't complain too much about it.
Leave it easy. Right.
No, I don't know why I was passing out. Okay, so I need you all to be working on this right now. So what you're gonna do? Listen. Okay, listen please. You have 14 problems. You are pulling out the greatest common factor. You will find your answer below. Okay? And then you're going to go to the top. And the letter and all your twos. So on and so forth. Okay? And it will give you a fun fact. So I want everybody to work on this by themselves right now. I'll give you probably about 7 minutes or so to work by yourself. And then I'm going to ask you to pair up with somebody and look at your answers versus theirs. And then we're going to go over it. Yes, sir.
When you give it like the X, you just add 1 to 4, it gives you 4, like 4. Just like 4, like 4.
All right. What do you need? Why is your computer so out on your desk? I don't know. I don't know. Oh, boy. They're working on individual stuff right now. Is it still light enough in here to need a light on?
This one.
And yes, the joke is corny, the contract is corny, they always are. Y'all are on a roll. I'm so glad that the method I taught you today has you a better understanding of greatest common factor. No, no. What is 15 divided by 15? 1. Here's the handout I have so far.
Can you return project?
Yes, please. And I'll give you my notebooks. You can work on the first part of it. Yes. Okay, at this point, I want you to get with a partner. Anyone in here that your little heart desires. And look at your answers, compare your answers, finish if you have not finished. Okay. Good. Thank you, ma'am. You know me, anything I make you do in class, I collect and grade. I don't force you to do anything that I'm not going to give you credit for, that's not fair. If you work for me, I give you a grade for it.
Did I put 14 wrong?
Just wrote the wrong letter?
Yeah. Oh, mine's similar. Connect the dots to find your path.
I told you it was corny.
When something like that.
It's all good. I'm going to really enjoy grading these projects. Super excited about it here. Great. Guys, I'm sorry. I need a light on. My old eyes are not cutting this right now. Y'all have young eyes. I have old eyes. They're just not cutting it right now. It got a little too dark. We need to be careful about what's in front of us on the course. So you can't pull out. So there's no numbers to pull out on that one. You can only pull out their pictures. Sorry, I'm cracking myself up over this lame joke.
It's not even a joke.
Fun fact. Fun fact.
It's not even fun.
It's not fun, it's just a fact.
It's not.
I don't even know if it's a fact.
It is a fact. Yes. I will pull up the picture. I will pull up the picture. It is a truth.
I never like paid attention to that.
Yes.
Actually not.
See? So it is a fun fact.
It's not fun.
It's not fun.
You're
It's
so,
a fact.
so hard.
You're killing the spirit.
It's not fun.
You're just trying so hard to make it clear that this joke was
It's funny to me. It's hilarious.
Wait, pull up the picture.
See? Kinsey says it's hilarious.
Put up a picture of it.
They're only kidding.
Luana doesn't have any eyebrows.
Wait, this is.
She doesn't have eyebrows?
No, she doesn't have eyebrows. She doesn't.
Let me see.
All right. So, what is our fun fact of the day?
Luana doesn't have eyebrows.
The Mona Lisa doesn't have eyebrows.
Wait, put like a picture of it.
It's
I
not
will-
fun, but I
Listen.
guess it's a fact.
All right. I got you. Here we go.
It doesn't seem right. It doesn't sound right.
It doesn't seem right.
It's not legal.
It's not legal to not have eyebrows.
No.
Grandma has no eyebrows.
She has arches, but she has no eyebrows.
I don't.
I noticed that.
I don't buy it.
I'm not buying it.
Hold on.
I noticed it when I was in like fourth grade. I saw my teacher.
There is no eyebrows there.
Oh, wow.
That is the curve above her eye. That's her actual bone
Why does
structure.
she not
But
have?
there are no eyebrows.
Why does she not have eyebrows?
Somebody needs to pencil those in, right?
That's wrong.
That's just wrong.
I'm pretty sure you would get sued for this.
Yeah, please don't go to the museum and pencil them in.
I do it.
And I'll take a picture of it and send it to you like I told you she had eyebrows. Take a picture with it like, doesn't she look better?
She looks better now. She has eyebrows, Miss Smith.
Miss
You
Smith-
will so get charged for
Miss
that.
Smith will get me for jail. She has eyebrows.
Mo's gonna be calling me. Please come bail me out. I got arrested for drawing on eyebrows.
I don't know how much time they're gonna give me for drawing on eyebrows.
So I can give everybody credit for that. Please make sure your name's on it. Pass it up and pass it to Elijah. You're fine.
What if you get it?
Huh?
I got like.
The Mona
If you
Lisa
need
has
some extra time to
eyebrows.
finish it up, you can turn it in.
Elijah.
Monday, that's fine.
Up into Elijah.
So, we're not going to be able to do the task cards I have today, but we should be able to start this factoring. Okay? And we'll do the task cards on Monday before we start factoring by group.
Does that mean
Probably.
Yeah, it's not.
Not okay. I just made it up.
You just say 100.
Thank you. Thank you. Okay, so your second foldable for today is your notebook. Again, gets folded in half, just like the first one.
The last four.
Listen, it's better than sitting there and tediously cutting out stuff, right?
No, I like cutting.
You like the cutting better? Oh, thank you.
Just saying.
Shelby's just saying.
And I'm upset.
Do we need to turn the lights off again so y'all can see this better?
Yes.
Okay. I can see in the lights. It's just when I was going to help you, I'm like, I can't see this writing on this paper. Again, old eyes versus young eyes. Don't get old.
We don't have a choice of that.
I know. All right. So we did greatest common factor first because that's the first thing you always need to check when you're factoring. Okay, so anytime they're asking you to factor, you want to look at your polynomial and say, do I have a greatest common factor? That's step number one. So if I've got 14x squared minus 12x minus 2, Muhammad, what does 14, 12, and 2 share in common? 2, good. Okay, they share a 2 in common. So your upside down division sign and a 2 on the outside. So that means we need to divide everything by 2. So, Shania, what's 14 divided by 2?
7.
7. Quentin, what's 12 divided by 2?
6.
Thank you. And finally, what's 2 divided by 2, Allison? 1. Oh, yes. Thank you, gentlemen. You can just set it outside when you're done. Okay. So, minus 1. Okay. So now I've got 7, 6, and 1. Is there anything else that divides evenly? No. What about my variables? I've got 2 x's, 1 x, and none. No. So I'm finished. Okay, that's my greatest common factor. That's step 1. Now we're going to continue on. Okay, so not only can you pull out a greatest common factor, you can also factor the remaining. So we're now going to factor the 7x squared minus 6x minus 1. Okay, so I'm changing it up this year, and we're going to do the box method because it works with everyone, and it's the same steps every time. So your x squared term goes in this top left box, 7x squared. In this bottom right box is your C value, or your constant, minus 1. Okay, this only works if you're factoring trinomials. Tri means what? 3. So 3 terms, 7x squared minus 6x and negative 1. Okay, so now to fill in these other 2, I need to find factors of negative 6. What can I multiply together that gives me negative 6? 2 and negative 3. Careful, that's still the same thing. Negative 2 and 3, good. Okay, what else? 6 and negative 1. Good. Negative 6 and 1. Okay, so I need you to equal all of these. If I do 2 minus 3, that leaves me with?
1? No. Negative.
Negative 1.
And then 1.
And then 1.
Negative 5. I mean, oh, crap, 5. And negative.
You said 5 and negative 5.
I wrote it down.
Okay. We want to pick the numbers. Why do I feel like that's wrong right now?
Wait, you said we subtract.
I feel like I totally just did something wrong right there. And now I can't figure out what. Hold on a second. No. I'm not used to this box method, and now I've got to double check my life. No, because I did factors of 6 instead of factors of 7. I lied. I'm so sorry. Oh my goodness. That's where I went wrong. Okay. I went wrong. Oh my goodness. I'm having a bad day. All right. Let's back that train up. Back that train up. Okay. I need you to do your A term times your C term. Oh my goodness. A term times your C term. Okay. Remember, when we did standard form of a quadratic, my A term was what? The first one. My C term was the last one. So we're going to do 7x squared times -1. What does that give me?
-7x squared.
-7x squared. All right. Now we need factors of -7. -7 and 1. And -1 and 7. All right. Now add these up. So we're at -6 and +6. All right. This answer needs to match my B term. Which one of these answers matches my B term? -6. Okay. This has to match this. So that means that these two numbers right here are my factors. So in one of the boxes, I want you to put the -7. And in the other box, you want to put a 1. Okay. Don't forget, though, we have an x squared. To get x squared, I would take x times x. So that means each one of these is going to have an x with it. Okay. Now, we just practiced greatest common factor. You're going to do that across the top and down the side. So you're going to look at this and say, I have 7x squared and 1x. What do those two share in common?
X.
X. And you pull that out. And then you're going to look, -7x and -1. -1. Good. If they share a negative in common, you've got to pull that negative out, and they don't share anything but a 1. Now you're going to do it side to side. 7x squared minus 7x. There's a 7 in common and an x in common.
Doesn't matter what side of the box you put it.
No, you can put it on the right-hand side. It doesn't matter. Okay? And then I've got 1x and -1. Just a 1. These are now your factors. So your first factor is x minus 1. Your second factor is 7x plus 1. And then don't forget, this greatest common factor that you pulled out from the beginning needs to go in front of that.
That is so easy.
You've now just gone from standard form to intercept form.
You just confused me.
Okay. Hold on. I know, because I lost some of you because I totally just screwed up that one. All right. Open up the page. We got some more. Yes.
It's actually easy. You explain it really good.
All right. Let's see if I can not screw you all up this time. All right. I have 9x squared, -6x, and -15. What's the first thing I need to check, Jalicia? What do I need to look at first? Your greatest common factor. Okay. So What do all three of these terms share in common? Three. Okay. So we need to pull out a 3. Rebecca, what's 9 divided by 3? Okay. Lauren, what's 6 divided by 3? And Shelby, what's 15 divided by 3? 5. Okay. Oh, I forgot the x. Nice call. Okay. 3x squared minus 2x minus 5. Anything else in common? No. Okay. So now, 3x squared, top corner. -5, bottom corner. Multiply those two together. That gives me what? -15x squared. Okay. I need factors of -15. -3 and 5. And then -5 and 3. Okay. -15 and 1. Fantastic. Okay. Get me some totals. -3 and 5 give me 2, which means the opposite gives me -2 and 14. Which one matches my middle term?
-5, 3.
-5 and 3. So that's what goes into my boxes. -5 and 3. Don't forget, it also had x squared. So x and x. Okay. Now we pull out what they share in common, up and down as well as side to side. So what does 3x squared and 3x share in common? A 3 and an x. -5x and -5. Fantastic. Okay, left to right. 3x squared and -5x. X. And 3x and -5. Just a 1. Okay, just a 1. So your first factor is 3x minus 5. Your second factor is x plus 1. And again, bring over the 3. Okay. So how would I check myself?
By plugging it in, right?
You don't need to plug it in. How do I check myself here? How do I solve? Good. Okay. So Rebecca says I need to take this and I need to multiply it through. So I need to take, I would start with your binomials and then multiply that through. So when I multiply my binomials, your first term, does everybody remember FOIL?
Yes.
Yes.
I like
It stands for what?
First, outer, inner, last.
Yes, ma'am. Yes. Okay. First, outer, inner, last. So my first term, 3x times x. 3x squared. Outer term, so 3x and 1. 3x. Inner terms, -5 and x. And finally, outer terms, -5. Now what? Combine your like terms. So 3x squared
Minus 2.
Okay? And then the last thing you need to do then is multiply your 3 through to every term. So 3 times 3, 9x squared, minus 6x.
15.
Does that match what I started with?
Yes.
Your answer's correct. Okay, take a look at your next one. 2x squared plus 3x minus 9. Okay, Elijah, do I have a greatest common factor? Do they share anything in common? Elijah says no. Okay, 2, 3, and 9, nothing in common but the 1. Okay, so there is no greatest common factor in this one. So we skip that step. So again, we've got here here. Your A term and your C term. Multiply them together. What do we get? Okay. Lydia, give me one factor of negative 18. 2 and negative 9. So I'm going to reverse that and do 2 and positive 9. Okay. Jeremiah, give me another factor of 18, negative 18. 3 and positive 6. And we should have one more factor. Teresa, what do we got? Good. Okay, so 1 and negative 18 and negative 1 and positive 18. So my goal is to find a 3 here. My goal is to find a 3 here. Which one's going to give me my 3? 6 and negative 3 is going to give me my 3. You okay?
Yeah, I thought you meant like a 3 in the factors. So that's why I was using.
No, I want when you add them together, what's going to give me that positive 3. Okay. Okay. So I've got a negative 3 and an X and a 6 and an X.
Does it matter what?
No, it does not matter which block you put each one of them in. You can put the negative 3 underneath because either way you're going to catch that cross. Yes. Because you need it to multiply together to give that X squared. So we got the factors of 18. What multiplies together to give you X squared? X and X. Okay. Good question. Okay. So let's do up and down first. 2x squared and 6x.
2x.
2x. Negative 3x and negative 9.
Negative 3.
Negative 3. 2x squared and negative 3x. And 6x and negative 9. Careful, does the 6 have a negative?
3.
Just pull out the 3. Okay, only pull out the negative if your lead term's negative or if you have 2 negatives to pull out.
Wait, so what would go in front of these two? Or would just
Going, it would just be a 1 because there is no greatest common factor. So you don't have to write anything. Okay, so we've got 2x minus 3 and x minus 3.
Plus.
Oh, I'm sorry, plus. You're right. Plus. Wow, Miss Smith's really off today.
But it could be like.
I think I need to take a nap. Do you think we have enough for you to try the bottom one on your own?
Yeah, I got it.
Come on, try it. Try it. See what you can do. Yes, you've got this. You've got power. Do, 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 do. You don't need to put anything there because it would just be a 1. And when you pass through a 1, it's just the same number. Actually, when you go through and FOIL it, though, it's going to give you the opposite answer you're supposed to find. Believe it or not, it will move you up. Come on, Zell, you got this. You got this.
I got it. So
Yes, ma'am.
what happens with the negative?
You see it?
And we need the greatest common factors that's gonna give us what number?
Huh?
It's gonna equal to what number?
So after I saw that, it's just gonna be.
It'll be Okay, hold on. All right, Rebecca has a good point. I know, for once. Bless you. We love you, Rebecca. Okay, Rebecca has a good point. So she went through and said, no GCF, right? Okay. So then she said, okay, I put 3x squared here and I put 4 here. Well, when I multiply, I get 12x squared. So it's a positive, which means I can do 3 and 4, and I can do 2 and 6, and 1 and 12. Okay. But then she said, hold on. How do I get that negative in the middle? Where did the negative come from? Okay. When this is a positive 12, when I multiply, positive times positive gives me positive. What else will give me positive?
Negative times
Two negatives. So when this middle term is negative, that means that I need to have positive or negative. And when the middle one's negative, they're both going to be negatives. So your actual factors are -3 and -4, -2 and -6, -1 and -12. Okay. So anytime you're doing factors and it's a positive, you have to look at that middle term. If your middle term's negative, your two factors are both negative. If your middle term is a positive, your factors will be positive. Huh? 3 times 4. Your 3x squared times 4. Your a times your c value. Yes. A times c.
Okay.
Right? Okay. 2, 3.
I was just pull out the eggs.
You're going to pull out the negative because it's negative in the front.
But it's,
Okay. Hold on. Okay. So we're here. Correct?
Yes.
Everybody's gotten to this point. Okay. So not only do we pull out a negative when they both share a negative in common, but take a look at this. So 3x squared and -2. What do we pull out? Just an x. Okay. -6x and 4. 2. Okay. When this leading term is a negative, pull out a negative. Okay. When your leading term is a negative, pull out a negative. So that means when I go across here, I've got 3x squared and -6x. So 3 and x. Good. Here I've got that leading term again that's a negative. So I pull out a negative, and this is going to be a 2. Because it's on top or to the left.
I don't understand.
So whenever there's a leading term of a negative, that number will go a negative. But if it's like if the leading term is in the second block, like where the 4 is, and it was not a negative. Okay.
Mo, think about it this way. So I need negative and negative. So that just means no matter what my factors are, I'm going to have minus here. So if you don't like the whole leading term, pull out a negative. If you've got to have 2 negatives here, it's got to be 2 negatives there. Okay. Because take a look up here. So when I had a negative and a positive, look at my finishing factors. I finished with a negative and a positive. These were negative, positive. I finished with a negative and positive. Because these two are negative, negative, I need to finish with a negative, negative. Okay. So my final factors here are x minus 2 and 3x minus 2. So you have 3x minus 2 times x minus 2. Same thing. That does not change it. Okay. No, that does not change it.
The
Yes.
homework, did we also do that in here or no?
Okay, so you do not lose this page, I want you to go ahead and glue it in on page 44. Okay. We did not get done exactly what we needed to get done today, but it was good conversation.
We don't got no homework.
No. What I want you to do is I want you to try those last 3 problems in this foldable. That is it. I want you to try them. We will go over them on Monday.
That's the homework?
That's your homework.
So we did
11, right?
Yeah.
No, that's 10. I know, but if we don't finish it.
I don't see what else can give you, what else come up on you.
Oh, there it goes. And because your middle term here is positive, that means it's positive.